Alrighty, so later on we're going to talk about some challenging exercise. So if you have access to a computer, just go to the lecture site. At the end, exercise on iterator pattern and generics. We'll start that on the halfway through. We want to finish a little bit more basics about the iterator pattern, and then it will make sense to do the exercise. Okay, so this is our motivating example. Okay, so this from our discussion last time. Every time if there's anything from the supplier side that you think is going to change constantly, you better hide it. That should become private part of the supplier, so that any change on the supplier's implementation would not affect the client's code. Okay, that's what we said last time. Okay, it's called information hiding. You can review the definition as well. We're gonna keep emphasizing information hiding in this course. Okay, what I would like to do now is to talk about the architecture for the iterator. Okay, and this is done using the same tool that you are required to draw using your labs. In your lab. So I'm just use that as an example for you. Okay, so now let's go to the diagram. You can also download the diagram from the website. So bound diagram for iterator pattern. Okay, just clearer. Okay, so now I'm going to zoom in first of all to what you should pay attention to. When you look at the diagram over there, first of all, you can see there are two clusters conceptually. So we have the client's cluster. We also got a supplier cluster. Okay, overall, two clusters. And then you can see that, first of all, on the client side, I simply just make a bank. So you will find that this has correspondence to the bank example we use in the complete post-condition lecture. Okay? And now, this is what you should pay attention to. If you look at that, from the client side, we say accounts should be iterable of account, rather than array or linked list. What does that mean? That means throughout the lifetime of this particular bank application, you can feel free to change the underlying implementation from array to linked list, or from linked list to hash table, or to whatever. However, any change you make is not going to affect the clients. That's kind of why we are doing this pattern here. And notice that we have a client supplier label over here, right? Remember how you can do label. And the accounts is effective. That's why I put a plus over here. Okay, so that's about the client side. We'll see lots of examples from the client side, how you can use across. Okay, we'll get there. So now let's talk about the supplier side, which is more relevant to what we expect you to know. Okay, let's see. From the supplier side, that's the complete picture. Okay, we also did a little bit walkthrough yesterday in the lab, but let's do it again for repetition. Okay, so now first of all, you have two deferred class over here. One is called iterable. The other one is called iteration cursor. Okay, so these are the two things you need. And how are they connected to each other? It is the cursor that you want to return. Every time you want to make your own application class iterable, you have to first of all make sure it is a subclass of iterable. That's where you start. Okay? After that, you will be required to implement this particular new cursor feature, which is of type iteration cursor. And now iteration cursor itself is deferred because it got item, after, and fourth. So all these are deferred. So that means there should be some descending class implementing it. So now you got two scenarios. Scenario number one, if your particular application class, I'll give you an example in just a moment. Your application class is making use of, let's say, any of the base collection classes in iPhone because they are all iterable and they are all effective. So it's guaranteed their new cursor feature must exist. That's why I put new cursor over here. They're being just effective, right? So that means you can use it for free, okay, in the simple case. In the harder case, like in your lab number 2, you have to somehow create your own cursor class, in which case you have to just create a new subclass over here, okay? And then it's a subclass of iteration cursor, in which you have to implement item, after, and fourth, okay? And of course, implicitly, there should be, let's say this is your application, iterable, and this is your own cursor. Implicitly, there should be a client supplier between them for the new cursor, right? Implicitly. Okay, that's the overall picture, the harder case, right? That's exactly what you have to do for lab 2. But you definitely have some compilation issue that should be sorted out. We'll talk about it in the exercise, okay? Now let's just worry about how you should add the code. Let's go over very quickly 2 cases, okay? Let me just wipe this out so make it clean. So we talk about the 2 cases again. It's really important for you to know the architecture. Okay? And I would say, from now on, since we talk about design, this course is about design, you should really be feeling more comfortable by starting with the design diagram as opposed to the code. That's something we'll gradually try to train you, right? So usually, when I introduce a new pattern, I'll try to show you just design diagram first as opposed to code. Okay? Any question briefly about this diagram here? Any notation that doesn't make you comfortable? Okay? So now let's see this. Okay, let's talk about easy case first. Easy case, very easy. Okay, that's also in your slides. So what we're doing is we're basically saying we have a card class, and now because it has only one single attributes array, which is also an existing collection class, that is effective. Guarantee its new cursor feature must be defined. That's an easy case. Okay? So what we do is, first of all, we have a card class. If you think about it, architecture-wise, we are basically having a card class over here that is effective. And we want to inherit that from iterable, right? That's exactly this inherits clause you're seeing. And we're just saying that every client who is going to go across this card, they're going to get one order at a time. That is why you're seeing order over here. But in your case, of course, it's tuple, right? It's a little bit more complicated, but we'll get there. Okay? To make it not so confusing, because usually green, we mean client supplier. So I will simply just put red over here. So it's inheritance. Okay, in this case, no more new classes to create, because now we can directly use orders.new cursor. What that means is, because we know that the card has a client-supplier relation into the array over here. And to put a label, you want to look at what's the name of the attribute here, right? That's orders. Okay, go back there. You can say orders effective. Any question? Yes?
Where's the new cursor diagram again?
New cursor? You mean the effective one or the deferred one? Okay. You're basically asking about new cursor, right? Number one, the pattern itself, iterator pattern. You have the iterable, also you got iteration cursor. The way to connect them at the abstract level, at the pattern level, is by having new cursor, but this one is deferred, number one, okay? Huh? Sorry, you want? What's the meaning of defer? Oh, I'm surprised you're asking me this, okay? That means, anybody? Abstract, unimplemented. Okay, be careful. Okay, defer just an IFO term, to be honest. Usually we say unimplemented or abstract. Okay, just be careful. Okay, so number two, the new cursor we have in this case is, look over here. Because now we talk about the implementation being an array, right? Array is itself effective, means it's implemented already. So it's guaranteed it has a new cursor feature already. So we're basically using this for free. It's been given to us. That's the easy case. Okay? The harder case simply means you don't have any cursor for you to use directly. You have to create your own cursor class. That's the extra complication. Okay? Let's have a look. Okay, that's the easy case, no problem. What about the harder case? The harder case, let's have a look. Also, I made it simple, just one generic parameter. We'll talk about more than one generic parameters a little bit later. Let's say we have over here generic book, simply G. However, now this adds a little bit more complication. We'd say this guy here inherits iterable of something. So now, how do we interpret this? That means any potential clients who's going to iterate over a generic book, they're going to get one item at a time. What should be the type for each item? It should be a tuple, whose first element is string, and the second element is generic parameter. Okay, that's how you interpret that informally. And okay, we got names, we got record, that's why we got string and G, right? Usually just include all the necessary components in the tuple. And then, now the problem is, names itself is an array. So you can say names.new cursor. Also, records itself is also array. You can also say new cursor. You got two new cursor objects you might want to use. But now the problem is, the return type for the new cursor over here that's required by iterable is only expecting a single iteration cursor. You cannot return two iteration cursor just for one, right? So we have some inconsistency over here. That is why in the harder case, you have to somehow customize what the cursor should be like for this particular application. Okay, that's a complication we are adding. Okay.
So what's your definition of records in this case? Does it represent key values there, as in like?
Okay, I'm over here. Okay, just an example. So it's more like a book where you have a name of the person and also you have the record of that corresponding person. Yeah. Okay, so now for, and typically, as I mentioned before, iterable, whatever you put inside the iterable, this record type over here, like each item, they should be the same as whatever generic parameter you put over here for new cursor. New cursor is like a cursor object that will be returned at the runtime. Whatever you put over here, I'll make a note. Whatever you put over here is going to be item return by each iteration of the cursor and typically they should match. Okay. Now in this case, we simply say the local variable is simply a class that we create by our own, by ourselves. In your case, maybe data set, iteration cursor, or whatever, right? Depends. Okay, let's see. Well, how do we change the architecture diagram, right? So now we have to add two classes over here in the diagram. Number one, we have the book generic. Yeah, let's not worry about generic parameter now, just for illustration. Okay, book itself is effective. You're going to inherit from there. Okay. However, notice that. Let me just draw a little bit more carefully here. So now, because we know that the book is using two arrays, right? You can think about we are basically having a client-supply relation also to the array. But now in this case, it's names and records. So it's now names, effective, and records. But the problem is, how can we combine these two things into a single cursor? That's the tricky thing, right? So what we do instead is to say, now we're going to create a new descendant class over here, and then it's going to be book iteration cursor, let's say. Okay, that's going to be effective. Yeah, just one moment. Yeah, and the way you define that is by saying item, after, and forth. You have to implement them all in this particular class. So that's why it's effective. Yes, question. Good question. So the question was, where should we inherit from? So the reason we are doing this is because what you're suggesting, why don't we simply inherit this class over here from indexable iteration cursor? That's your question. It would also work. However, it's more like trying to say, because think about the pattern itself. I cannot think of any good reason why it shouldn't, but let me try to explain. Okay. So if you think about a pattern for iterator, it's basically about iterable and also iteration cursor. That is why whenever you want to instantiate a pattern, you simply go to iteration cursor and go to iterable, right? However, the reason that we have this particular type over here is only for indexable data structure, like array, linked list, but for example, tree doesn't belong to this category. So iteration cursor itself is general enough for any cursor you want to create. Okay, yeah. Okay, that's good. It's more like a design decision you want to make. Okay, okay, that's the book iteration cursor. And then one more thing I want to point out, which is also important. Okay, between the iterable and also the iteration cursor we're creating, there should be a client-supplier relationship over here, because now notice that it's very important. The idea really is we want to somehow hide details from this particular book. We want the clients to only get access to the iteration cursor class. However, in order to let the iteration cursor to be our representative, you have to pass all the internal structures from the book into the book iteration cursor. Okay, let me just write it down very quickly. Okay, that's something you have to see when you program it. So now this one here, it will pass internal data to the cursor objects. That's why you got a client supplier. And how do we see that in the code? If you see the code, look at the book iteration. Oh, first of all, when you look at the generic book, the iterable objects, the class, you can see when we try to create a my iteration cursor, what do you pass? Names and records. So these are already hidden from the client, so you're just passing them to another class, right? They will also be hidden. If I switch the context to another one, so now this is my iteration cursor that we talk about. You can see the names and records from the book. They're also hidden, so that's fine. So clients will never see these two, okay? What you have to add additionally is something like a cursor position to keep track of where you are when you do the iteration. So now I leave them as ... over there. So that means how you actually implement these three deferred features from the iteration cursor is up to you. But if you want hints, feel free to follow the tutorial video. It'll give you a little bit more hints there, okay? But I think the general architecture is more important to lay out, right? Any questions? Okay, I think this last slide over here for the harder case summarizes the architecture for the harder case, right? So you can see under iterable, we have the book. Under iteration cursor, we have my iteration cursor, right? Between the book and the my iteration cursor, we have the new cursor feature. That's what we have to implement, okay? So it's kind of nice, square diagram over here that you have to understand. Questions?
Could you explain one more time how the passing of feature works?
Oh, how passing the data? Yes, sure, no problem. Yeah, so the question was, how do we exactly pass the data, right? Thinking this way. So now, let me use a different color here. Okay, so now we know that in the book class, we know that names and records, they're simply just private. They're hidden. Okay, no client should see them. That's a purpose for iterator pattern. Now the idea is somehow we want the clients to only be able to call the following three features. They should only be able to call item, after, and fourth, and nothing else. However, every time if the client calls item, how does the cursor know which item they should get from? So that means the cursor, we have to pass the access to the cursor only, right? So in that case, what we will do is we should say, so these private features, they should be passed to the cursor. This is exactly how we pass them. That's a constructor. You pass the array and the array, right? That's how we pass them, conceptually. So in your lab 2, how many internal structures do you have in the repository? 3. So you may want to pass 3 of them, all 3 of them to the cursor. However, I would say you may be able to pass just 2, but it's not important. As long as you can make it work, that's fine. Okay, think about it. Okay. Yes?
Can you explain how, why in this example here and in the one in the lab demo, why these two are switched?
Oh, yeah. So you're basically asking about how the generic parameters should be organized. I'll talk about it. Yeah, that's why I gave you this separate exercise. We'll get there. Okay, any questions about architecture in general about iterator pattern? Just make sure you're comfortable with it. So now the plan would be, now we try to see from the client's point of view, how can you use the across keyword in different way. That will give you a little bit more insight, and then we'll be ready to do a challenging exercise. Yeah.
Iterable, basically, the parameters as passed is what is supposed to be returned every time the client iterates through.
Correct.
And it's able to do this we're supposed to implement the new cursor that we inherit from the iterable. It uses from the iterable.
Correct. So basically, what you let me just highlight once more. Whenever you're struggling with what should be passed over here as the generics, again, think about what should be the item to be returned back to the clients one time by one time. Okay? Yeah, we will see more example. Yeah, tuple is a very common type, tuple. Yeah, if you program in Java, maybe pair. Okay, so now, so that's about the runtime for iterator pattern. I'll leave that over here, okay? But you can review the parts that we talked about last time about runtime. Okay, let's not worry too much about it, okay? Oh, you know what? Just highlight one thing quickly, okay? So now, what's going to happen at the runtime? First of all, names and records, and these, all the internal structure, they are completely hidden from the clients, okay? That's why I put them just in black, just in dark color. On the other hand, you can see that the only thing in green that means the client can get access to is the new cursor, first of all, just the new cursor. the clients can call new cursor from whatever that's iterable, and then once they get the cursor objects, they can use item, after, and forth. That's it. And somehow the cursor is going to get access to the underlying structure. It's going to iterate through one by one. Each time it's going to somehow return a combination of the values somehow, right? And this is going to be the item. Return by, let's say, the first iteration. And now, what should be its type? It's up to your design decision. You can make it a tuple, right? For example, you can make it a tuple. Maybe it's, let's say, string and G, for example. I'll just make one example here. That's one way to go. Or you can also customize another class. Maybe you can simply create a class called record. And the record class simply got two attributes. One is of type string. The other one is of type G, right? That's also going to work. So that's the typical two ways to think about what the type should be for each item that's returned by the cursor, okay? All right, that's about the diagram here. Okay, let's now do something a bit light, and then we'll go to the challenging exercise. What I want to now go over is how you can use something that's iterable, okay? I'm basically presenting the slides over here just on iPad, so we can just do a little bit more annotation here. Okay, so now let's have a look, so we can practice some contracts, okay? So now, number one, let's say we have a class called checker, okay? And then we have a collection whose type is iterable of integer, okay? So now let's say, this one's easy. Let's say we have a Boolean query to see if everything in the array, everything in the collection is positive, okay? So now that's how you can use it, right? You can say across the collection, and remember the collection is iterable. You can only iterate through using across something that's iterable. That's the requirements. And now let me give you a little bit more details, okay? Something you wouldn't see explicitly, however that's done implicitly for you. Whenever you're trying to say across certain iterable is item, okay? What will be achieved under the hood is like this. It's going to call collection. If I tell you that something is iterable, what feature will be guaranteed to be available? New cursor. That's exactly what's going to happen under the hood. Okay? So new cursor will be called on collection, but you don't need to do it by yourself. If you say across, it's going to do it for you. Okay? So now it will say simply item, and every time item will just be the item that's returned by the cursor. Okay? That's how it works at the runtime. Okay? Okay, now let's see another example here. So now we have another class, another example, let's say bank, and then we have list. By the way, list is also iterable. So that's why you can also cross over it. So now you can say, oh, interval over here, as we said, is also iterable, right? Just one thing I noticed from your lab one, some of you made a mistake. Remember, if you want to create a heap out of the array, you want to somehow go in the reverse order, right? That's what we said. Now, some of you try to do, for example, 10 down to 1. Well, if you ever try to test your code, you realize that's not right? It wouldn't work. What it will happen is, it doesn't really go 10 down to 1. It would be nice if that's the case, but it's not the case, okay? What is that equivalent to? Empty interval. Yeah, that's okay, empty interval. The way to think about it is, if you say this is I, you're basically saying for all the I, that's larger than or equal to 10 and less than or equal to 1. Iterate through them. Do you have such I? No. So empty. So whatever you write within the across is useless. It will never be executed.
So if I ever want to do something like this, I would have to just drop it.
Not necessarily. It's a good question. I think it's worth mentioning. I'll give you a little bit idea. Okay, you have to play around with the loop counter a little bit. Let's say, for example, if I say across 1 until 5, I'll just make it small, okay, is I. If I simply say io dot put integer, and then I will simply say I. We know that very well. It's going to be 1, 2, 3, 4, 5. But what I expect to have is, let's say, 5, 4, 3, 2, 1. Okay, let's say. How can we play around? Definitely playing around with this wouldn't work. Why don't you try to play around with this thing? I heard 5 minus I, are you sure? 4 minus I, are you sure? It's okay, it's okay. Are you sure 6 minus I? Okay, 6 minus I. All right, you can see 1 plus 5, 6, right? 2 plus 4, also 6. Yeah, just be careful, that's fine. Okay, just one example, yeah. All right, good. Let's do another, this one here, I'm just using interval. I'm just saying integer interval is an iterable, okay? Let's do another one. Aha, this one here. Let's say we have also a bank class. That's something iterable. Now, how do we say the array or the iterable contains no duplicates? Okay? Actually, that's something you had to do for lab 1. I forgot, right? Okay? So I believe most of you got it, hopefully. So now let's see how I would do it, right? It doesn't have to be efficient. I know some of you try to be very clever about playing with the indices, so you never repeat the I and J you're trying to check. That's absolutely fine. I just want to show you that. Of course, it will be up to you as an exercise to translate this into across. Okay, that's also this part of the coverage for lab test 1. You want to try that. Okay, so what does this really mean? We're basically saying the following. We are having 2 dummy variables, I and J. So whenever you want to introduce a new dummy variable in the quantification, you have to have another nested across. You cannot simply say across I, J. No, you cannot do it. Okay? Now, so now the idea about this particular implication over here, let's try to read it to help you a little bit more on the implication. It is saying that if the current accounts I'm looking at position I, and also the accounts I'm looking at position J, if they happen to be the same, how do I know if they are duplicates or not? How do I know? Well, I'm saying that if they are in the position, in the same position, so what does that really mean? They're the same one. But would that be duplicates? Not really, right? So for example, basically, I and J, first of all, is going to consider all the combinations of the indices, right? So one could be, if I got I here and J here. In this case, if this account is the same as this account, I got duplicates, okay? However, what I'm trying to say over here is, if I talk about I and J being the same, that's one of the combinations for the 2 indices, right? In that case, should I care? In that case, I shouldn't care, right? That's exactly what the implication is saying, okay? That is trying to say if they are the same, that must be the case that, well, we're talking about the same. Otherwise, you will just have to fail because it contains duplicate. Think a little bit more about this particular nested quantification. I would say for the purpose of this course, this might be more or less the most complicated thing you have to write. You know, with some nested quantification, and possibly with some equality, some implication, etc. Okay? Study this a little bit more, and if you got trouble, let me know. Okay? So we don't have to waste too much time on this in the class. Okay? Any question about this? We okay? All right. Which dot? Oh, the dot. Okay. It's just one way to write a predicate. Maybe your 1090, maybe your professor write it a different way. That's okay. What I'm trying to actually between the vertical bar and this. So this guy here is the range. Okay, that's a range. And then this guy here is a property. Yeah, don't be too bothered by this. You know, if you simply say colon and colon, that'll be fine. Okay, I wouldn't worry so much about it. Okay, let's see another one. This one show you very explicitly how you can use something that's iterable. So now again, we have accounts that's iterable, okay? And then with some precondition, let's not worry about it. So now we simply say we declare a local variable that's iteration cursor of account. That means instead of using across over this particular iterable, we go a little bit in direction. We go to say, get the cursor from the iterable, and now we use the cursor to get access to each item. A little bit different way of doing things. So now what we do is we simply say cursor objects over here is assigned to accounts that new cursors is guaranteed to be available because account is iterable. Okay? And then how do you use a cursor? Basically you say until there's no more position in the cursor to be go over, right? That means you're reaching the end. And then every time you want to make sure you move the cursor one position after. Okay? And then every time how do you get the item being pointed to by the current cursor position? Just say item. So you can see after item and fourth are exactly the three features from iteration cursor. Okay? Inherited. Those are deferred in the iteration cursor. Yeah.
Here, since you're using iterable, not an array or like a linked list, so aren't we supposed to have like a new class for iteration cursor?
In this case,
Where did you get that cursor?
how did I get a cursor from? Good question. You're basically asking, accounts is of static type, iterable, right? How do we know whether the underlying object is either linked list, array, or something else? The answer is, for you as a client, you don't have to know. Because all you know is it's going to be something that's iterable. What's the underlying structure for you as a client, it's not your concern. You will just use it. So whenever you're being returned a new cursor, this cursor might be a new cursor from an array, might be a new cursor from some hash table, or it can be some customized cursor. So now we talk more about the client's point of view.
Yeah, but you call the cursor iteration cursor from iteration cursor account. So wasn't it supposed to be like a custom?
No. So again, you can see you're talking about this particular type over here. So if you look at that, first of all, it's iteration cursor of account, right? If you recall the hierarchy, so iteration cursor itself is deferred. Agree? And then in reality, you have many subclasses that other supplier just implements their own customized cursor. So now you're saying that for this particular accounts over here, simply give me your new cursor, whatever it is. So from the client's point of view, whatever the actual object is not your concern. Okay? Question? Yes. Fourth, sure. You can think about the new cursor over here. The new cursor over here is simply just going to return a new iteration cursor for the accounts objects, right? The accounts in the starting position. That's really important. In the starting position. So that means as soon as you get a new cursor objects from there, it's going to be ready for iteration. What about the fourth? Fourth over here is going to say move cursor to the next item. Right? One is to get the cursor ready initially. The other one is to say between iteration, you want to move the cursor from left to right, right? By one position. That's the difference. Okay? Okay, let's see one more. Okay, so let's see another one here. Okay, now we use a cross, right? So whenever you say, okay, now the card itself, assuming that the card that we talk about, the card itself is also iterable. Okay, that's card class. That one there inherits the iterable. Okay, I'm just sketching the diagram. So that means the card can be supported using a cross. So now, question for you. When at the runtime, what's going to be done implicitly over here? Right? Well, since it's a cross, that means IFO is going to call card.newCursor for you. Okay, just as a reminder. Okay, and you're going to use the cursor to iterate through one by one. Okay. So now we just talk about clients, right? Using it is easy. Okay, it's not supposed to be difficult. Okay, so now I guess one more. Okay, before the challenging exercise, so one more. Okay, so now again we got accounts over here. So it's iterable. Okay, and then let's not worry about the precondition. So now you can also use a cross loop. So I just show you across loop or across all, doesn't matter, right? So if you across loop, all you can do is you can just go over item one by one, and now again you're going to call accounts.cursor, new cursor. Okay, and then you can just do different stuff over here. Okay, yeah.
Just like want to clarify something. I think I saw the slide and it's saying across something as cursor. It's like the same way that what you're saying is across this order or something like that.
Yeah. So here, well, I would say I wouldn't worry so much about the subtle issue over here. So whether you use across as or across is, okay? Yeah, you don't have to worry too much about the subtlety, right? As long as you know how to use these. So when you say across something iterable as something, and then you say across something iterable is something, okay? All you have to know is under the hood, implicitly, IFO is simply just going to say whatever this iterable is going to call that new cursor for you, okay? That's all you got to know, okay? Yes?
So given that it calls new cursor, if you did it the hard way and you implemented new cursor with your line indexable cursor, let's say, that means the compiler is going to call actually your implemented cursor to check against what check the.
Okay, you're basically talking about static type checking, right? That's something we'll get into maybe next week when we review the inheritance. To make it brief, okay? So when the compiler doesn't do any execution, compiler also only do things statically at the compile time. They only check to see as long as the collection clause is iterable, they're happy, because the guarantee at the runtime, new cursor will be available. So now, remember dynamic binding from 2030, right? At the runtime, exactly what new cursor will be called, either from array, from hash table, from some customized iteration cursor class. It depends on what's the dynamic type for this particular cursor object, but we'll get there. Be careful because every design pattern we talk about, maybe not so much in the iterator pattern, but every design pattern later after the reading week, we have to use dynamic binding a lot and polymorphism. So that's why we're going to review it next week. Okay, one step at a time. Okay, ready for the challenging exercise? Okay. Can I assume everybody at least have an idea about what the classes are? How about I give you about 1 minute? Okay? Don't worry about the numbers I put over there. It's meant to be as a reminder of what step we can take, one way to solve it. Huh? Oh, no, don't worry. Ignore the numbers I put over there. Just ignore them. Ignore the handwritten stuff. I want you to take just 1 minute quickly, at least to see what classes we have. And also the two kinds of relations we have. We got inheritance, we got client supplier in green. Okay, that should be not so strange to you. Have a look, and then whatever that's been blue out is something that we want to figure out. Okay, and I want you to notice one thing. If you look at the generic parameter for database, it's GH, right? Now, if you look at the generic parameters for item iteration cursor on the right-hand side, I deliberately made it not GH, MM. Okay? Because in general, you cannot assume what kind of generic parameter supply will use, right? That's the point, okay? Okay, take about 1 minute just to see what the classes are, and then we'll go over the answer, okay? And then I got another slide exercise for you based on this, okay? Hopefully that will help you. Is the font size too small? You think it's okay? It's okay, right? Okay. This is more like a simplified version of your lab 2. Your lab test number 2 will be somewhere between this and your lab 2. So this is more like a lower bound. Your lab 2 is more like an upper bound, somewhere in between, somewhere. But no, you don't have to worry about it now. Okay. We'll talk about it when we get there. Okay, another 30 seconds. Okay. In order not for you to get lost, that's why I want you to spend a little bit of time just to see what classes we have, right? Okay. At least everybody is aware of what classes we have, right? At least, right? We got new cursor, we got iterable, we got iteration cursor, right? We also got our customized iteration cursor. Okay. So now, here's the rule for the challenge, right? Everything we set over here cannot be changed. For example, you cannot swap the order of MMN in iteration cursor. No, that's not allowed, right? You can only say, based on what's given to you, what should be the one that's blue out. Okay, that's kind of the idea. Okay, so now we can follow the number. The number kind of suggests a particular way to solve it logically. Okay. Okay, let's go here first. Okay, you should always start with what basically think about the test over here is more like the client's expectation. We'll go with that. Think about the test case is more like a documentation, something agreed between the supplier and the clients. So you must satisfy that. Okay. So now, number one, I put it around here. Okay, number one. So now, question for you. Okay, so now, I want you to look at this guy here and this guy here. Can you see it? Okay, these two. So now, in this case, what should be G? What should be H? Should be G. Okay, very good. Yeah, that's kind of, sorry, easy. So now I will put in red. So that means when we talk about string here, that means G. Oh, let me a little bit. This is G, this is H. Number one, very easy, right? So now, let's go to step number two. Step number two, actually pretty much the same. Okay, step two we don't have to worry about. Okay, just number one. So now let's go to 3.1. Okay, 3.1 over here. Let's look at this line over here. Remember what we said before. What will be done implicitly? New cursor, call on DB, right? Implicitly, we know that it's going to be DB dot new cursor. Okay, new cursor is exactly over here. Agree? That's new cursor. So somehow the type of T can give us hints about what should be filled in over here. You see what I mean? Yeah. Okay? Guys, I can go a little bit slowly, that's fine. But you can stop me if you get lost. Okay, so now, somehow we know that the T over here is a result of calling db.newCursor. And then this will give us hints about how to fill in this type for the new cursor for the database. Okay? So now, here's a question. In order to do that, what should we put over here? Oh, remember I said 4.1 and 4.2. Iterable and iteration cursor, they should be consistent. So we can figure out 1, 2 should be the same. Okay? Now what should that be? Tuple? How do you do a tuple though? Yeah, don't assume it's going to be a tuple, right? The reason that it should be a tuple is because T is over here of type tuple. Because you know that T is going to be put into this particular tuple's linked list. Each element is simply just a tuple of integer string. Okay, so far so good? Now, good. Important part. We know that it's going to be a tuple over here. I agree. This is also going to be a tuple. Tuple of what? GH, GH, or HG? I heard GH, I heard HG. I would say in this case, what you figure out for step number 1 is very crucial. Because step number 1, we know that for this particular instantiation, string is G and integer is H. So now integer string should be HG. Okay, I'm pretty sure that's something new to you, right? Okay, so now we know that accordingly this should be HG. So that should be tuple HG. And that should be tuple of HG. Yes, you may. How did I figure out that's a tuple? Good question. The way I figured that out is, first of all, we know that T somehow is getting from db.newCursor somehow, right, each time. And new cursor over here is going to type something over here. Okay? Now, notice how T is being used. T has been extended into the tuples. What's tuples? Tuple is declared exactly over here, which is a linked list of tuple. That's how we figure out that should be a tuple. Okay? Maybe I don't necessarily have to put it as a tuple. I can put it in something else, right? Okay, so now what have we figured out so far is this. So this guy here should be tuple HG, okay? Tuple HG, okay? Did you get it right, at least? Maybe not. Would you get partial marks if you put it GH? Maybe not. Well, if you do it in the lab test, you get 0 because it wouldn't compile. If you do it in the exam, you also get 0 because that's wrong. Right? Be careful, right? That's why I want to go through this with you. But you know, everything should make sense. Okay, so now after 4.1, 4.2, let's now go a little bit, switch the context a little bit to item iteration cursor. Okay, so now we want to figure out this guy over here. Oh, I didn't want to wipe it out, no. What should be this guy? Right, that's a problem. I will give you a little bit hints. So now I want you to look at this local variable over here. Oh, I'll give you hints. Look at this local variable here. First of all, it tells you we are declaring item iteration cursor. Agree? Okay? And then item iteration cursor is referring to this. Right? Normally, if you just have GH, that'll be very straightforward. If I deliberately want to trick you, I can say HG. I could, but I thought that might be too much. Right? So that's why I put MN. Okay? So now let's say this. So now what can you refer from there? If I have H and G over here, so that means M means H, M means G. Agree? You see, the feeling you want to get is the way generic parameter works, just like a variable replacement, like how you did it in algebra, math. Okay. If you hate math, nothing I can do, right? Yeah. So now that should be HG. So now, question for you: what should be this guy here? First of all, should it be tuple or should it be what? Well, the reason that there should be a tuple is, I can tell you that every time, once you decide the iterable to be something, that should be something consistent throughout for the iterable. Okay? So now I'll put tuple here. So now what should be this guy? If naively, you might think that should be HG. Because HG over here, consistent with HG, and also consistent with HG. But is it going to compile if you put HG here? No. Why? Yeah, exactly. Remember, okay, let me emphasize again. Some of you asked me after class last time. Think about whatever you declare at the class level, M and N in this case, are all the generic parameters you can use for this particular class. So that means you can only use N and N, nothing else. G and H simply doesn't make sense in this particular class. We're just using it to reason about. Okay, having said this, what should this be? MN or NM? NM? MM. Good. All right. Because MN simply corresponds to HG, right? So now, if you didn't understand anything about what we're trying to say, if you didn't attend this particular solution session, you'll be wondering why in this particular database class, we got GH, HG. But here, we got MN and we got MN. Right? That's something I want you to really get comfortable with, right? Okay, so now we still got something left. And then I can ask you one more question. MM, okay? Oh, and also, once we have solved this, it will solve this guy here as well. Because remember, let me tell you this. Let me give you one more insight. What should be this guy here? Item. So we already solved. It should be iteration cursor of tuple MN, right? Excuse me. So now, what should be 5.2? Tuple of MN or tuple NM? How do you know it shouldn't be swapped? Reason. What should be the reason? I'm trying to explain to you, right? I'll give you a little bit hints. This class. Yes? Oh, nothing to do with make. No, nothing to do with it. Nothing to do.
Because the item that's being inserted into tuple is of part AG, we're putting through here AG, which is MN. So
Yeah, exactly right. Okay, here's the reasoning. Because we know that when we say inherits iterable over iteration cursor over here, we are instantiating the G over here into tuple MN. Agree? So that means every occurrence of G over here will just be corresponding to tuple MN. And this is simply just another case for, remember when we talk about using generics lecture, we say you can replace every occurrence of G by string, or every occurrence of G by account, right? The same idea. So now, and let me finish one sentence. As soon as we instantiate this particular G by tuple of HG for this particular iteration cursor, every occurrence of G will just be tuple of that. Okay? That is why you will see tuple NN. Question?
Where does the G become?
Instantiated?
Yeah. Where
Sure.
does
Yeah.
the path-
Yeah. Okay. So first of all, let's understand this. You can see iteration cursor itself has one single generic parameter, right? That means when you want to inherit from this particular class, you gotta instantiate that G into something, right? You can only one single thing. You can instantiate that into a string, an integer, or in this case, a tuple. Tuple is a single object. Okay. Good. Over here. Okay, we got a final puzzle to solve. Number 6. GH, are you sure? Okay, well, first of all, if you simply say GH, I assume you mean, oh, sorry, not this. I assume you meant GH. Are you sure? We are calling a constructor, right? You should give some variables. G and H, by the way, capital G, capital H, they're only type parameters. Okay, so basically, okay, we got two possibilities, right? So now let's see. Either you can say GS, HS, HS, GS. 1 or 2? Good. This can definitely be an exam question, right? Okay, let's be logical, okay? Before I say any answer. Let's be logical. Now, first of all, in order to figure out what this should be, go to the make feature, how it is declared. Go to the make feature over here. First of all, it says new NS and new MS. Okay, but it doesn't really matter what the names are. Look at that, array of N, array of M. Array of N in this case means array of G. Array of M, as we said before, array of H. Okay, so now we just go backwards. So now that should be, oh, sorry. That should be GS, HS, right? Number 1. All right. Yeah, no problem. Go ahead.
So it's here initialized to be HG, right? Would it make any difference if we initialize it as GH and then switch the class based on that? Would it make a difference how we're instantiating item iteration?
You mean, okay, tell me the line. Okay, so I can be more specific.
So for item iteration cursor,
For item iteration cursor, okay, which line?
so we initialize it as HG, right?
It-
If we switch the local DB cursor,
Oh, you just want to play with them. Okay, I would say you're basically talking about what if we try to play around with the order. We do have an exercise like this. I think that will answer your question. Okay. Okay, guys, first of all, before I go to the additional small exercise to reinforce your thinking, any question? Yes.
For the first part, when you were comparing the two, that for this one we have switched the HG.
Tell me the number. Tell me the number. 4.1 or?
Okay, let me ask this.
Offline. Okay, guys, I tell you what, this is tricky, right? So I hope at least the process is clear to you. Study this carefully. That will make your lab 2 life much easier, I hope. All right. Alrighty. Exercise for you. This is the answer we just derived. Now I want to make 2 changes. Look at the local variable over there. Let's say now I want it to be such that When I instantiate the I10 iteration cursor, I want it to be, rather than HG, I want it to be GH. Question number 1, is it going to compile? I would say this. Okay, that's okay. The answer is it wouldn't compile. The intuition is usually when you swap around the generic parameters, that means you're somehow contradicting with the prior consistent usages of those parameters. So usually it wouldn't compile if you switch around. However, if you switch around in multiple places, it might work. If you only do a single switch, it wouldn't work. Okay? Let's say this. Having I10 iteration cursor GH is really what I want to stick to. I don't want to change it. So now, how can we somehow modify I10 iteration cursor so that it's going to work? Okay, I heard some, okay. Let's be logical here. Well, we're going to do some swapping, right? Okay, let's see. As we said before, okay, MN over here is simply, MM now is a G and H, right? So now it is G and H rather than HG, first of all. That's how we start with. Okay, and now the consequence of that means it's now going to be tuple of G and H. GH over here is contradicting with HG over here. That's why it's not going to compile. If you try this in iPhone Studio offline, I would suggest you try at least. This is kind of the message you'll be given. However, I would say typically it would not be very easy to understand, usually. Doesn't matter which compiler you're using. Even in Java, it will simply tell you type wouldn't match. So having this kind of reasoning in your mind would be very beneficial. Okay? Okay, now we know that why this wouldn't compile. How can we play around with it? So one way to do it is, actually the only way to do it, okay? You want to say over here, so now this is where we use the parameter. We know that having GH is not right. Swap them. So it's going to be N, N. Is that the only place? Where? I10. Yes, exactly. You gotta swap this as well, because now you're instantiating your iteration cursor to be tuple of MN. So that means the I10, so this will be tuple of NN. That's what you have over here. You want it to be consistent for every occurrence of G, right? So now that means this guy here should also be NN.
Why can't we just change the very first line from M to MM? And then N would be G, and then M would be H, and everything else would be the same.
That's kind of interesting. Yeah, that might work too. Yeah, interesting. Yeah. Yeah.
Switch the places of the arrays.
Oh, do we have to switch the places of the array? Oh, that's interesting. Do we have to? The question was, okay, so far so good, right? So your question was, should we swap the order of the array? Let's figure that out, okay? Let's say over here, GS, HS, right? This is G, this is H, right? What about here? So now N will be H. So this will be G. I agree with you. Yeah, we should swap them too. Okay, very good. Very good. Guys, so that's something, okay, what Shady just mentioned. We should also swap the order of these two, simply because. So now, since now we got G and H over here, you want to make sure it's actually now consistent, right? Over here. So that's why you got to swap them. Question?
So wouldn't it be just kind of add a class?
Yeah, that's what your colleague just mentioned. Yeah, that'll be a little bit, yeah. Maybe I will simply put a constraint. You cannot swap the order of the class declaration. Yeah, I know. You guys are very smart. You know, you can find a way around. Yeah, good. Of course, if in the question I said you can do whatever change you like to fix it, right? You can definitely do that, no problem. Yeah, I might put some little bit extra constraint, so it's easier for us to mark, right? Yes. You mean change the order?
Yes.
I will leave that as an exercise for you. Okay? You're basically asking this question over here. Think about it, okay? I think we've done enough exercise just to get you a little bit interested, right? You're basically asking, should we change the parameters over here? Okay? try that in eStudio to see if you should, and then try to confirm. If you've got trouble, come to me. Okay, good. Okay, any questions in general? Yes.
So nothing over there for that class, like this class,
It's
going to be a problem, right?
Yeah, there might be other places you got to change. Since we're not only focusing on this particular item iteration cursor, there might be other things. Yeah. All right. Okay, enough challenge. Let's do something simpler. How about that? Is it fair to say this is something you haven't seen before? Okay, good. You're learning something new in this course. I'm glad. Okay. By the way, this is not specific to iPhone. Any programming languages that support generics, this applies. Okay, so valuable technique to know. You might be saying, why don't we just rely on the compiler? Number one, usually when things go wrong, solving this kind of problems using a compiler messages will be quite difficult to track. Okay, number one. Number two, if you go to a programming interview, your employer, your future boss, asks you to explain what's the iterator pattern. You want to somehow sketch the ideas. You don't want to get something that will be contradictory, right? If your future boss asks you. So you want to be a little bit more clear about how things should be instantiated, how things should be laid out. Right. All right. Okay, that's about everything what I want to say about the iterator pattern. So now it should be good for doing lab number 2. You got enough time. Yeah. Yes.
Professor, that's why we're seeing Pablo suggests which implements both, which shows the composition pattern. Can we expect to see a collection of a collection, like for example, a tuple with an array list or a tuple with a list?
You mean in general?
Like for expectations for like a lab test.
Oh, for lab test, I would say for lab test number 1, basically as long as you follow the guides properly and do the exercise, and also the lab 0 tutorial video, right, about how to do bank, how to do accounts. If you can also follow that, you should be okay for lab test 1. Like array of array of
Yeah, so for example, you have a tuple, right? Tuple can pull anything, so that tends to be like data structure.
So how complicated this structure might be depends on what we want to solve. As far as the example we do in the lecture is concerned, no. I'm not sure if we even have an array of array, maybe not. But for your projects, you may want to use it, right? Depends. Okay. All right. Okay, let's do a little bit more slides. Okay, everything has been said, so let's now go to a different topic. So now we're done with iterator pattern. So what we should do now, we should go for another one, singleton pattern. But before we do that, let's do a little bit of design feature over here. Good. Okay, so before I present this from your 2030, you learn about aggregation, you learn about composition, right? What's the difference? Anybody want to try? No one? What's the difference between aggregation versus composition? Of course, they're different, right? That's why I'm asking. Yeah, want to try? So in aggregation, we have sharing, we got aliasing, we got sharing. What about composition? We don't have sharing somehow. However, remember in 2030, the way we have to implement composition is by having some copy constructor, right? Sometimes you may have to make sure the way copy constructor works is make sure there's no aliasing going on, so there's no sharing. However, it might be a little bit difficult to make sure the copy constructor works perfectly when your object structure is very complicated. Okay, so now there is something called expanded type, which is basically like composition. It's more like a modeling concept, okay, for us to learn about. Okay, but I'm trying to say the expanded class is not really a brand new idea. It's just a feature for modeling. So sometimes you might find that for your particular application, there's certain components that you shouldn't allow for any sharing. It's just an integral part. Okay, I'll give you examples. Okay, so integral parts of some other objects and not to be shared. Okay, let's see this. Let's consider this. Each workstation has its own CPU, monitor, and keyboard, and all workstations share the same network. if you read it, this description over here, pretty much like your prison lab, right? No two workstations should share the same keyboard, right? But they all share the same EECS network, right? So now, can you see composition there? Yeah, for example, what's composition here? Oh, are you sure network is composition? Are you sure? Yeah, well, the other one, right? Well, yeah, exactly. CPU, monitor, and keyboard, right? These are not shareable between workstation, right? So they should be composition. And then network should be shared. Okay, to draw some diagram, something like that. Actually, do I have the diagram? Yeah, I do. That one would be a little bit better. Okay, over here. Okay, basically over here, I just want to point out, when we talk about aggregation, it's really about sharing, right? You can see workstation number 1 is sharing the same network as workstation 2, as workstation 3. So these are simply sharing. Okay, easy concept. On the other hand, you can say this is independent keyboard, not to be shared. There's another keyboard, right? Similarly, CPU, monitor. They're simply integral parts, right? Not to be shared. Okay, idea is simple. All you have to know now is to see a little bit how we can do that in this language. I'll move it quickly. It's not difficult. Okay, so now let's say this. Let's say we have 4 classes. We got keyboard, we got CPU, we got monitor, we got network. Okay, so these are the 4 things. We know that keyboard, monitor, CPU, they should be compositions. And network should be aggregation, right? Should be sharing. So now this is one way to achieve that at the design level. Okay, so now let me explain that. Wow, you can actually see the difference, right? How we declare the types. Let's look at the last one. When I say N is of type network, it's just normal reference type, which means it allows sharing. On the other hand, every time if you believe for this particular variable or attributes, it should not be shared among objects. It should never be any aliasing, sharing going on. In that case, one way to do it is by putting expanded. Okay? At the runtime, it's going to be make sure every time you try to do any aliasing assignments between the keyboard or between the CPU or between the monitor, it's not going to be achieved. Okay, that's composition. Okay, that's one way to do it. Okay, and number 2, another way to do it is by at a class level, we say that every keyboard, every CPU, every monitor is expanded by default. It's already expanded, so that when you declare keyboard over here, that means it's composition. So now, question for you. Can you see the advantage of number 1 over number 2? Somehow number 1 gives us a little bit more flexibility, a little bit more. How can you see that's more flexible? Yeah, exactly. You can see for the version above. Okay, let me go back to the version above so you don't get distracted. And we look at this version over here, at the class level, all the 4 classes are simply just ordinary classes. You only say, when I want to declare a particular variable, I specify either that should be expanded or not. Okay? So that's the flexibility. Maybe for some particular setup, you want to share the CPU among different workstations, let's say. In that case, maybe you can take out the expanded keyword, right? In that case, it becomes sharing. On the other hand, once you get this, it's fixed, okay, typically. Okay, so now let's try to study a little bit behavior quickly about expanded. Just want to show you, so you wouldn't be so surprised if you have to use it. Okay, I will switch to code, do a little bit tracing. Okay, so now we have seen this already. Okay, this one. Okay, just see what's the behavior. Okay, so now let's say we do this. We have expanded class called B. Okay, and then we have a command change I, and of course we have attribute I. Of course, you can export that to none, just to hide. Also, we're going to change the new I into I. Very easy. Let's just study the behavior. So now let's try to do over here. So result EB1 and EB2, expanded B1, extended B2, basically. Okay? So now when we do result, do you think, first of all, do you think this might have any voice safety issue? when I simply say eb1.i directly without creating it. No, actually what? No, no, no. I is integer. eb1 is not, is b. You're half right, almost right, yes. Because that's expanded, first of all, you can see b here, eb1, eb2, there's simply b, which is expanded, okay? So that means you wouldn't have the void safety issue because what they will do for you, even before you try to execute anything over here, they're going to initialize eb1 and eb2 automatically for you. So it's just there, okay? So now at this point over here, right after line number 4, what you would get is eb1 is simply, oh, okay, now, the way to visualize the objects of expanded type, you shouldn't really draw pointers. Usually when you draw pointers, that means you allow sharing. eb1 is simply referring to this particular objects of type B, and then it simply contain just I being 0. It will simply give the default value for every attribute. That's what they will do, just default value. And then what about eb2? Same. It's expanded, so all the attribute will just be assigned the default value. Okay? Simple case. And then let's go to the next line. That's why when you try to check this particular result, so it will be 0, 0, 0, 0, so true, no problem. Okay? Let's go to the next one. Now, a question for you. If I try to do result eb1 equals eb2, what are we comparing? Are we comparing references or are we comparing something else? I wouldn't blame you. Yes. No, actually, that's not references. Because if eb1 and eb2, they are of reference types, then definitely when you say eb1 equals eb2, you will be comparing references. But now, because eb1 and eb2, they are of expanded type over here. So what you're doing over here is the equal sign for expanded types, it compare contents. Okay? It's as if you try to call that equals on each other. It's as if. Okay, so now, but in this case, it's going to be true because you will simply compare the contents of these two expanded objects. One is 0, the other one is 0. They will simply do a comparison under the hood for you, compare every attributes. Okay, so this will be, okay, true. It's a bit odd, but it actually makes sense. If you want to compare two integral parts that belong to different components, how do you compare them? Because there's no sharing, so it doesn't make sense to actually compare their addresses. You just compare their contents.
So if we had in class B, if we had more than just arrays and other stuff,
yes,
would it also compare them too?
Correct. So the question was, what if the expanded class B is more complicated than this setup? Okay. Let's say, okay, I'll mention to you just in general. Okay. Let's say if you got another attribute, let's say A, array of integer, for example. What they will do is, when they, at this point, they will also try to initialize the array for you. Simply initialize the array of just empty array, and there's simply no integer. But you may just update that array later. The idea about expanded type is simply that you wouldn't want to do any aliasing, any sharing, right? Just integral part. Okay. Okay, having said this, now if I say eb2.change I, I'm just making a feature call, right? So now if I say eb2, which is this object here, change I to be 15, right? It will just be 15. It's not going to change I. Oh, eb2, right? Oh, sorry about that. Yeah, sorry. eb2 over here. So change that to 15. Thank you. All right. So now it's obviously the case when changing this to 15, it doesn't affect this value over here, right? So 0 and 15. Okay, no problem. So now finally, when we check this particular one, okay, what are we comparing? Contents or address? Contents for expanded type. So now this should be True, because their contents are different. 0 versus 15, okay? Yeah, 0 versus 15, right? So that would be okay. Okay, it's a very quick illustration of expanded type. I would say we don't, as far as the examples we're gonna show in the class is concerned, we only need that briefly for the singleton pattern. But whether you want to use that for your project, it's completely up to you. But I want to show you this such feature. Basically, think about back in 2030, you will use composition where you don't want to do any sharing. But the price is you have to pay is you have to do the copy constructor yourself. But now in IFO, you can also achieve the composition by just using expanded. But you don't have to do any copy constructor yourself. You just implement it for you. Okay, that's the difference. Okay. All right. We got about maybe 10 minutes, 15 minutes. Okay, let's do a little bit more. A little bit more. Question? Yes. Good question. Yes, we'll definitely get there. There's a slide. The question was, let's try. If I say, let's say put in orange. If I say EB1 is assigned to EB2. Now, take a guess. What's going to happen? Yeah, somehow you're going to do a little bit assignments, right? However, don't think it's going to say EB1 is now pointing to EB2. No, that's the wrong thinking, right? No sharing, remember? No sharing, okay? That's not the way to go. What's going to do is whatever content that's in EB2 will be copied over to EB1. So simply copy every attributes that's in EB2 into EB1. So you'll change that also to 15. But they're still separate objects, no aliasing. Yeah. That'll be a deep copy, yes. In some ways, a deep copy. It's going to be a recursive copy. So depending on what they point into, they might point to some very complicated object structure. In that case, they'll do a deep copy, yes. Mm-hmm. All right, let's go on. Okay, exactly what I said. So now let's do a little bit. Actually, this one is going to summarize what you just asked. Okay, so now how do we interpret different operators at different contexts? Okay, so now basically in Java, every type is either primitive or reference. Okay, in IFO, every type is either reference or expanded. Expanded means no sharing, right? If you think about primitive type in Java, there's also no sharing, right? You cannot share the address of an integer. You can only do that in C if you have the address operator. Okay, okay, in reference types, okay, so now let's say you got X and Y both being reference type. Let's say they're both array heap, for example, right? So now if you say X is assigned Y, in that way you're not copying any contents, you're just copying address, right? That one's easy. Okay, now X equals Y will be comparing address, right? We talk about reference type, don't get confused. In expanded types, so let's say X and Y are both expanded, so now when you say X is assigned to Y, copies the contents, okay? If you say X equals Y, it's basically essentially the same as X tilde Y, compare the contents. Okay, it's a quick summary. Guys, questions? All right, experiment with the expanded when you need it, okay? But I just want to make a reference to you. We do have something like that for composition. Okay, one interesting issue for you to think about. How do you model or design for this particular problem? Let's say every published book has an author. Every author may publish more than one book, right? And then, should the author fill, let's say for every book class, we have an attribute called author. Now, should the author attribute be reference type or expanded type? Okay, why reference, first of all? Why not expanded? Yeah, it seems like each author is more like a single object, right? I agree with you, that's one scenario. But what if you're trying to model, let's say, physical copies of book? Let's say, if an author published 10 different books, so every book has the author's information. If you somehow try to modify the information on one physical book, is it going to affect the other ones? Not really, right? So in this scenario, it should be expanded. So the answer to this question is open-ended. Depends on what you need. I will say it again. Let me just show it to you. If you can think about if you try the reference version, That means every book object is pointing to the same author. If you think about, it's more like if you have like an author, like a web page. Whenever you click on the author's link, you go to the same page. If you modify the web page for the author, it's going to be reflected to every link. On the other hand, let's say, what about the expanded version? Let's say you're trying to solve the problem for hard copies of book. In that case, this particular copy has the author's information, and this particular copy has another, have the same author. Let's say you publish a second edition of the book. In that case, the author's information might have changed, right? In that case, you may have some differences between the books. So which one to really use is completely up to you, okay? But now the bottom line is, whenever you want to use expanded, that means you don't want any sharing. If you want to reference, that means you want sharing. That's the bottom line, okay? You want to have that kind of a conceptual model. Oh, are we time? We are, right? Okay. Let me say, do you want to hear something about lab test? Ah.